Hello everyone, welcome to Mathematics with Shahab Yaqub. In pure math, when we study trigonometry or circular measure, or maybe differentiation or integration or differential equations, we come across this term which is radian. Now the question is, what exactly is a radian? Now in basic math, you have measured angles in degrees. Now there is a new unit in town and this is known as radians. Now the question is, what exactly is a radian? So first of all, let me draw a circle. Okay, that is a circle. Let me keep it over here. Now I need a line segment. So again, let me choose a straight line like this. And from here, the center of the circle, I have drawn a line till the circumference. This line, let me label this thing as CA. So CA is the radius. Now, approximately, this line goes like this. So this will be a rough figure. Let me draw a line on the circumference which is called an arc, and let me join again from the center till this point. That's another radius. What if I say that CA is the radius and this point is marked as B, CB is the radius, and this arc length which is denoted by S, this equals to the radius. If such is the case, this angle that is formed over here, this is defined as 1 radian. So what's the definition of a radian? Radian, 1 radian to be specific, is defined as the angle that is formed when the radius equals to the arc length of this particular sector. Now the second question arises, that is there any relation between the number of degrees and the number of radians? Is there any conversion that we can learn? Now first of all, let me draw the circle once again. So let me grab a circle over here, and this is a small circle that I've drawn. Now over here, the diagram will just be approximate. I'm drawing a radius from the center to the circumference, and over here I have drawn another radius. And if this diagram is exact, and let me just backtrack a bit, so approximately something like this. So this is O, the center, this is A, this is B, and this length over here, the arc length AB, that equals to the radius. Now the question is, the circumference of the circle is 2 pi r. That means how many arc lengths of radius r will be on the circumference. So let me just estimate it. This is A, this is B, and approximately over here, another AB would be there. So what I have done over here is this. This is arc length AB. Another arc length in purple color of the same length. Let me draw the third one in green, approximately like this. And then let me draw the orange one again. That is the fourth one, something like this. And then the fifth one again in purple, something like this. And then the sixth one is approximately like this. And then a little bit portion which I am shading in white is left. That means I have got 1, 2, 3, 4, 5, 6 and a bit more. In other words, 2 pi, if I write this in decimals, this is 2 into 3.142, which comes out to be 6.284. That means there are 6.284 arcs on the circumference, and it also makes sense to look from here. It was very obvious. I just illustrated it using a diagram. circumference is 2 pi r. That means there are 2 pi times this radius r. R is the arc length. That means 2 pi radians also equals to 360 degrees. That is the angle in one complete revolution of a circle, and that is the conversion that we need. So 2 pi is 360 degrees. Therefore, pi is 180 degrees, and I would prefer to use this format for any conversion. Whether the conversion is from angles in degrees and I have to convert it into radians, or the angles are given in radians and I have to convert it into degrees. I don't need to remember any formula. All I need to remember is this conversion. Pi radians is equals to 180 degrees. Now let me illustrate some simple examples for you. Let's first go ahead and convert degrees to radians. So degrees to radians, let's start with the conversion that we have, which is 180 degrees is pi radians. First of all, let me double this value. So 180 times 2, that is 360 degrees. So therefore, we will be getting 2 pi radians, which is the basics with we started. Let me do another conversion. 180 degrees is pi radians. This time, let's divide by 2. So if I divide 180 by 2, that is 90 degrees. Pi divided by 2 will become pi over 2. So that is the second important result that I get. Now let's continue with this flow. Let's take 90 and divide 90 by 2. So 90 by 2 is 45 degrees. Pi by 2 divided by 2 becomes pi by 4 radians. Similarly, let's take 90 again and let's divide 90 by 3. So 90 by 3 becomes 30 degrees. Remember, 90 is pi by 2 radians. So let's divide pi by 2 by 3. It will become pi by 6 radians. Similarly, let's take 90 degrees and multiply by 3. So 90 into 3 is 270 degrees. 90 degrees is pi by 2 radians. Multiply by 3. What do we get? That is 3 pi by 2 radians. Now also I can take this 30 and let me double 30. So 30 into 2 is 60 degrees. Therefore, pi by 6 multiplied by 2 will become pi by 3 radians. So let me jot it down, all these conversions in one place. So let me write degrees on the left and radians on the right. We will start with the very basic thing, which is 360 degrees is 2 pi radians. Next one, 180 degrees is pi radians. 90 degrees is pi by 2 radians. 60 degrees is pi by 3 radians. 45 degrees is pi by 4 radians. And let me scroll up a bit. And the last important one is 30 degrees is pi by 6 radians. So that is the conversion from degrees to radians. Now, what about the other way around? What about radians to degrees? Again, the standard is the same. That means pi radians is 180 degrees and we will use the ratio method. For example, if I'm interested in finding the conversion from pi by 8 to degrees. So what will I do? I'll simply say that if pi is 180 degrees, pi by 8 is 180 degrees divided by 8, which is the same thing as 90 degrees divided by 4, which is the same thing as 45 degrees over 2, which is the same thing as 22.5 degrees. As simple as this. Let me do another example. So the conversion is from radians to degrees. The standard is pi radians is 180 degrees. Now this time let me choose 5 pi by 6 radians and I need to convert it into degrees. So what should I do? 5 pi by 6. Basically multiplying pi with 5 and dividing by 6. So instead of pi, what should I write? 180 degrees. So therefore 6 ones are, 6 30s are, 30 into 5. That comes out to be 150 degrees. That is how the conversion is done. So what have we studied in this particular video? We have understood the concept of radians. What is a radian exactly? A radian is basically the angle formed when the arc length equals the radius. This is known as 1 radian. And one more thing, that is for degrees, we write, for example, 24 degrees with this sign. For radians, what we can do is that either we can write the whole thing, for example, 1.7 radian, that's one way of writing it, or we can write 1.7 with a small c at the top. What else have we studied? That is the conversion. What is the conversion? The conversion is pi radians equals to 180 degrees, and this can be used both ways. Either we can take an angle in degrees, convert it into radians, or vice versa. Till the next class, take care.